Here I have a list of raw scores that make up a raw score distribution, or just a distribution of raw scores. Next to each one of my raw scores, I have the corresponding z-score. I worked out the z-scores using the formula to convert from x to z. Now what I want to show you here for my z distribution is what the standard deviation is, not the standard deviation of my raw scores. I worked that out in an earlier video. That comes out to be standard deviation was equals to 4. And if you wanted, you could go back and check through that this set of numbers does in fact have a population standard deviation equals to 4. For this video, I want to find the standard deviation of the z-scores. Now, standard deviation of z-scores really is just a standard deviation. It's going to have the same formula that we've worked with before to find standard deviations. You need the root of your sum of squares over n, and to find the sum of squares of the z-scores, I'm just going to have the sum of my squared deviations from the mean, but now I'm going to be finding the deviations between each z-score and the mean z-score. In a previous video, I showed that the mean z-score is always equals to 0. So that'll make the math nice and easy to work through here. But let's get to work on it. So the first thing with a formula like sum of squares that I need to work with is the brackets. Brackets come first in any formula that you have brackets in, so inside of the brackets I have z minus the mean z-score. So I'm just going to do the brackets and ignore everything else. I also don't need to have this stuff over here. I don't need my original distribution. I'm just finding the standard deviation of this set of z-scores. So just pretend that this was just any set of scores. It wasn't these weren't z-scores. Just it's a set of scores. I want my standard deviation. So to do that, I need to first of all find the mean, which we did do. Again, I did this in a previous video. So I've got mean is 0. So now I just have to take each score, like negative 1.5, and subtract the mean. So I'm going to subtract 0. So that's easy. It means subtracting 0 means not changing anything. In fact, every one of these scores, I'm going to be doing subtract 0. So positive 1.5 take away 0 is still positive 1.5. 1 subtract 0 is still 1. And so on. So nothing changes here. And as a check, we can always check to see that our deviations come out to be 0, deviations from the mean. And of course they do here. If you add these up, you'll get 0. But we're looking for the sum of the squared deviations. We did the brackets. Next thing we have to do is exponents. So we're going to take each one of these results, each one of our deviations, and square them. So negative 1.5 squared is positive 2.25. Same thing here. 1 squared is 1. 0.5 squared is 0.25. 0 squared is 0. 0.5 squared is 0.25. So I'm doing this, remember, because I want the sum of my squared deviations from the mean. So what does this come out to be? Well, let's add them up. 2.25, or rather 2 1/4 plus 2 1/4 makes 4 1/2. This is 5 1/2, 5 3/4, 6. So I've got 6 as my sum of squares. This is the sum of my squared deviations. So I can now find the standard deviation by taking the square root of the sum of squares over n. That's going to be the root of 6 over, well, what is n? N is just the number of values that I was originally working with, and there are 6 of them. So this is the root of 1. The root of 1 is just equals to 1. So I get a standard deviation for my z-scores of 1. And once again, just like with the mean being equals to 0, where I said in that video that that's always going to be the case, a standard deviation of 1 is, again, always going to be the case for not just a set of z-scores, but for the entire distribution of z-scores. It's really important that you make that distinction. So the mean of an entire distribution of z-scores, not just a few of them, but all of them, is 0. And if I have all of my z-scores, so if I took all of my raw scores, converted them all to z-scores, the standard deviation is going to be equals to 1, always. It's I can show you how that works here as well. Let's or I can show you how to get a feel for what's happening with that. Let's look for a moment again at our raw distribution. Now, in the raw distribution, the mean was equals to 8. So here's a value, 8. So this is the mean right here. If I wanted to look at a score that is within 1 standard deviation, that would be, let's say, like right here. 12 is 1 standard deviation above the mean. It is 4 above 8. So this is 1 standard deviation above the mean. Have a look at what the z-score is. The z-score is a 1. That 1 tells me how many standard deviations I am above the mean. So this checks out. A score that is 1 standard deviation above the mean gets a z-score of 1. So keep in mind, when you're dealing with an entire distribution of z-scores, the standard deviation is 1, as well as the mean always being equals to 0.